To calculate the formal charges for NO2-, the nitrite ion, we're going to use this equation right here. And there are different forms of this equation, but they all give the same answer. So let's start by doing this oxygen here on the left. So we have our oxygen here, and oxygen has 6 valence electrons. You can look that up on the periodic table. It's in group 6A or 16, and it has 6 valence electrons. We're going to subtract the non-bonding valence electrons, the ones that aren't between elements. So we have 2, 4, 6 non-bonding electrons. And finally, we're going to subtract the bonding electrons. Here we have just 2 bonding electrons between the oxygen and the nitrogen, and we're going to divide that by 2, and 6 minus 6 is 0, minus 2 over 2. That gives us a minus 1. Traditionally, we'd put a minus 1 with parentheses. Let's do this oxygen here on the right. It's a little bit different because there's a double bond here. So we have our oxygen, we have 6 valence electrons, that doesn't change, minus non-bonding valence electrons, 2, 4 of those, minus bonding, and we have 2, 4 bonding valence electrons, which we'll divide by 2. So 6 minus 4 is 2, minus 4 over 2, that gives us 0. So we'll put a 0 up here. Now let's do that central nitrogen atom. So for the nitrogen on the periodic table, it's in group 5A or 15. We know it has 5 valence electrons. We're going to subtract the non-bonding valence electrons. These 2 up here are not involved in a chemical bond, so minus 2. And then we're going to subtract the bonding valence electrons. We have 2, 4, and then these over here 6. And we're going to divide that by 2. So 5 minus 2 minus 3 gives us 0. So we'll put our 0 up here, and we shouldn't be surprised that it's 0 because the overall charge is -1 for the nitrite ion, and we ended up with a total net charge here of -1. Those are the formal charges for NO2-. This is Dr. B, and thanks for watching.